Hi guys. No, I can't do it. I know you're supposed to start a video on YouTube like that, but I can't do it. Anyways, I want to post this video to show you a few issues that you may run into when you're starting to do your free fall computer model of student use, and get you a few tricks up your sleeve in terms of using the power of a spreadsheet or the power of computer to do repetitive things. So remember, the goal of this assignment is for you to be able to enter in just two numbers, two parameters, total flight time and the acceleration due to gravity, and have everything else be calculated for you. What's the initial launch velocity? What's the velocity at any given time? What's the height at any given time? So I'm going to put some numbers in there to start with, and some numbers that might be familiar from the worksheet that we practiced, so we can check whether our spreadsheet is indeed doing what we intend it to do. So I'm going to put in 8 seconds, and I'm going to imagine it's Earth. So the acceleration due to gravity would be 10 meters per second squared. I'm not going to show you how to do any of the physics calculations. So the initial loss velocity, you're going to have to figure out. I can clarify questions for you. I'm not going to show you how to populate velocity or height, but I will help you with flight times. And some of the techniques, the spreadsheet things we do here might help you with the other columns. So I'll go ahead and get started on that. What this column is going to do for us is take our entire flight time, which in this case was 8. Maybe we go outside and we launch a rocket, it's in the air for 6 or 10 or whatever seconds. And it's going to take that flight time and increment it into 10 or 20 rather, equally spaced times. So one thing we might run into, one issue we might run into when we're doing this is we're going to want to calculate the time. So I'll give you the idea of how we would do this. I'm going to take these time increments and I'm going to split our time up by that many. So one technique I might want to do is, I'm going to do a function. I'm going to put equal in there. And what I'm going to do is I'm going to specify, I'm going to take first time increment 0. So that's D2. I'll just click on that and it populates that. I'm going to multiply that by, and I'll use some open brackets here. I want to multiply this by the total flight time, which I might just put in as, well, I'll just do this, 8, right, because that's what it was, that, and then divided by 20, because that's what the time bracket I'm trying to put into. That should return 0, and it does. It makes sense, right? It's flight time. What I want to do then is I want to drag and apply that function down, and when I do that, it gives me flight times of 0 across the board. So what happened? We have to inspect the function, and one way to do that is to use the function control tilde. So I'm going to hit control tilde, and now it shows me the function in each cell, and I can diagnose what went wrong. So look what happened for the next one. The next function in time increment 1 used D3 times A3 divided by 20. Let me look over, well, what's going on with D3 and A3. D3 is fine, that's 1. But what's A3? If I come over here, A3 is there. It's right behind my graph, but there's nothing entered in it. And it's reading that as 0, and that's why we're getting that issue. So what we need to do is we need to fix this value as being used each and every time instead of trying to go down with it each column and using these zeros. And that's relatively simple to do. So if I want to fix a value, I'm going to use some dollar signs, and I'll show you how we're going to do that. One fix would be, well, let's just take A2 and let's just make it 8, right? Because that's what it is. And I'm going to go back to the function, control tilde, so it shows me the value. But that means I'm going to have to enter 8 in this cell every time I want to use this. And we only want to put in the number twice. So what we can do is take A2 is the number that I'm interested in. I want to fix it. So I'm going to use this, $A, $2. And it returns a value using that. So I'm going to hit enter. I hope I put that in the right spot. I didn't, guys. Hold on. I think what I did is I just entered that formula here. I need to enter it here. So let me just do it from scratch. Sign A, dollar sign, oops, $2. That divided by 20. Enter. Should return 0. Now watch what happens though. We should get non-zeros for these. And we do. So we can check, right? Our flight time was 8 and we wanted it incremented in 20s. So look what happens. We have 8 down there. So we should be able to use this data. Now, these are the times you're going to reference when you solve for velocity or you solve for height. One other thing I wanted to let you in on is that there are some other things, like we want to find max, we might want to find min or something like that. We can sort through things and use some functions that'll find those things for us. Let me quickly remind myself where they are. So here's some more. If I go down here to insert function, here's sum, average, count, max, min. There's some more. And this will give you an idea of the different things that we can automatically do with big sets of data. We can look through those. So if you need to know how do we do a square root, it's probably going to be in here. How do we square something? It's probably going to be in there. But let's go back here. I'm not asking you to do this, but let me show you how simple it would be with this data. Let's say I want to know the maximum time out of this data set. Well, we know the max time is 8, so we can check if it's right. But I might just do something as simple as this. Equals max, in the parentheses, and then highlight what I'm interested in, which is going to be this. There. Close it and hit enter. And it returns that max value. Right, so it's sorted through all those data and found the highest value, the max. And min will do something like that too. Average will average it for you. So those are going to be real quick ways to find these values. Time to max height might be a little bit different, but the max heights could be pretty simple. All right, guys, I hope that helps. Let me know if you have any other questions, and I will help you do that. Remember, this is working towards our last piece of this unit, which will be projectile motion, something moving sideways while it's falling. And we want to be able to quickly do those tedious calculations with a method like this.